going to look at a more complicated example of using this expression, based on the fact that we can calculate the concentration of one solution in a chemical reaction if we know the concentration and volume of another solution in the same reaction. To see what we mean, let's think about a neutralization reaction between an alkali and an acid in order to produce a neutral solution of salt and water. The salt solution, the acid and the alkali will all be aqueous, a solution in which the solvent is water. We can therefore identify a concentration for each of these substances, and as well as a concentration, a volume. We know that in this reaction, an acid and alkali will react together to give salt and water. If we have an alkali of known concentration, but an acid of unknown concentration, this unknown concentration of acid can be determined as long as we know the volume of acid and alkali that react together completely. We can calculate this unknown concentration as long as we know both of these volumes and the concentration of the substance that reacts with our acid. To see what we mean, let's look at an example, which is that if 40 centimetres cubed of HCl, or hydrochloric acid, of an unknown concentration, reacts completely with 35 centimetres cubed of 0.25 moles per decimetre cubed NaOH, or sodium hydroxide, the question asks, what is the concentration of the HCl in the units of moles per decimetre cubed? This question looks pretty complicated, but we can go back up to our table, and we can see it's exactly an example of what we were just talking about. We have an acid, hydrochloric acid, reacting with an alkali, sodium hydroxide. And the question has given us the volumes of sodium hydroxide as 35 centimetres cubed, and the volume of the acid, hydrochloric acid, as 40 centimetres cubed. It's also told us one of our concentrations. It's told us the concentration of sodium hydroxide, our alkali, as 0.5 moles per decimetre cubed. We therefore have all the information that we need in order to work out the concentration of the acid, and we're going to run through this step by step. As you'll know if you've seen our videos on titrations, this is the sort of data that you get as a result of a titration experiment, which measures the amount of acid and alkali needed to react together completely. The first step in tackling this sort of question is to write down the full balanced equation for the reaction that we're thinking about.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make chemistry at GCSE a walk in the park.